You and I were science teachers. And the way we have been teaching students to write is with CER. So students think CER is a science writing strategy. But in reality, people use claims, evidence, and reasoning all the time. Anytime someone asks, how do you know? They're asking for evidence, and usually they need some reasoning to go along with it. Just take a minute and think. Lawyers ask us to believe their claims. Doctors, when they're diagnosing us. Mechanics, when they're diagnosing our cars. Architects, when they're building a building or laying the blueprints. Meteorologists, when they're telling us what the weather will be like in the weekend. They all communicate this way. So maybe the secret to teaching mastery of CER in our science classrooms is that it's not just for science. It's how people communicate clearly every day. Hi, I'm Lisa, and this is Lab in Every Lesson. Now, I've been teaching science for 17 years. It's 2026 here, so going on the 17th year. And I want to say it was 2020-ish or 2021 that my school started this initiative for all open-ended responses to have this claim, evidence, reasoning structure. And we have a high school-wide standardized rubric for doing so. While this definitely on the internet is sold as a science writing strategy, at my school, we've been doing it across the board. And so over 5 or 6 years, obviously I've seen different cohorts of students learn, respond, show mastery differently. I'd say for the first 2 years, for sure, everybody understood a claim. The claim is the answer. Maybe in years 3 and 4, we got a little better at evidence because now remember in my school, all the teachers are doing it. So the ELA teacher's evidence is pointing at a specific paragraph or a line in the text or a specific quote. And in science, the evidence is actually like what we see or experience or feel or touch or taste, whatever the case is. It's a different kind of evidence. So it's taken some time to help my students distinguish what evidence is in various contexts, and reasoning still has yet to arrive. We haven't landed that plane yet. Reasoning remains the biggest struggle to teach. I'm really starting to think it's because they are preparing and producing these CER responses for their other classes, and that maybe the instruction, the guidance, the feedback they're getting there on what reasoning is different from science. I mean, I was even starting to get confused. Well, this is reasoning, right? There was even a period of time that I decided, well, I will teach this backwards because truly we can't come to a claim before we first think through the logic and the reasoning and see the evidence, and then we make a decision. But that didn't really work either. I mean, I've really struggled to get my students to, I think, understand what CER does so that they better understand what it is and then can produce one. Here's the thing. I don't want students leaving my classroom simply knowing how to answer a CER prompt. In everything I do, I'm trying to get my students to gain skills that will serve them long after they've graduated. So I want them leaving my classroom as like informed decision makers. Decision makers who ask better questions before they make those final decisions, and decision makers who recognize when someone has or has not supported a claim. Fake news, anyone? Communicating ideas so anyone, not just the science teacher, can understand them. Because science skills, of which clearly communicating is one, science skills are life skills. In the spirit of redesigning our approach, going from a lab and lecture kind of mentality, answering that question, how is it possible to not tell my students some things? We're going to go back to the last lesson I showed you in my video on reinforcing your science and engineering principles every day in your classroom where I talked about a reward system. And in the goals for that lesson, a big goal was to communicate clearly throughout the lesson as an active member of a brainstorming group. At that time, I shared students an activity where we would give them stickers and badges, and they would make some notes about what that really looked like to them so that they know how to continue on with a course, showing those behaviors and us positively rewarding them. Now, at the very end came clear communication. And this is typically when I would say to students, okay, now this is how we're going to respond to open-ended constructive response. We're going to call it CER. And of course, you could see here, I'm pointing out what is claim evidence reasoning? Why do I need to use it? And answering that question myself. That's the number one tip to inquiry. That's the core idea. That's what we need students to understand, not just how to do it, but what is it and why? Why do I need to do it? Because if we can get that buy-in, we're halfway there. Okay, well, I'm answering it for them. So we're going to transform that portion. What does it look like? Well, I tried at this point. Now I teach high school chem and maybe biology, so I have to reach to something simple, but still in the science sphere. So I'm not talking about like some random something somewhere, right? Or at least that's what I thought. So I reached for the solar system, and even that's really difficult because when you're asking students to make a decision, which is really what claim evidence reasoning is for, then they have to have a good bit of background knowledge. I'm asking them here, which planet the solar system moves the most quickly around the sun. That might be something someone memorized at some point in time, but the challenge with CER is proving it. So prove it. How do you know? And then I broke it down. Make a claim and what the claim looks like. Cite evidence and what evidence looks like. Provide reasoning and what reasoning looks like. But also in doing that, of course, I would give this, actually provided this as an ongoing reference every time they did CER, so they had something to look forward to. You might have something like this as a printout that's laminated that you give them as a bookmark, or you have even as a poster in your classroom. Explicitly telling them how to do it. Be sure to respond to the main idea. Every idea needs to be supported by evidence. And reasoning is facts. Okay, so we're telling them, here's a definition, here's an example, this is why we need it, all wrapped up with a bow. It seems good, right? I always thought it was pretty good. It's very colorful, it's very engaging. That's it. That's the CER lesson because I know what else to do. Naturally, the next thing is I just practice in class, and we use gobs of class time in my introductory unit. Do a CER, and then I'm reviewing students' individuals and giving them feedback, and we're going through it as a class. And that's all still going to be necessary for sure, because individual students learn at different paces and all the things there, right? But as an introduction, this is like a drive-by. Boom. Okay, what was that? What just happened there? So when I go about this year, it's going to look so very much different. Firstly, we're going to start with a warm-up. A warm-up that is, focused on the goal. I like to call this a review and preview because there's some aspect of it that they know, and there's some aspect of it that I want them to reach to. And sometimes it could be simple as get in a little group or do it yourself and brainstorm. Here are 3 examples of when and why clear communication has been or would be critically important to someone or to a situation. Now, I'll tell you how I came up with this. Is last year and the year before, I found myself, it was like a revelation. One day in class, I said, you know what? CER is like being a lawyer. You're making a claim, someone's guilty or innocent, and you have to show evidence, and then there's expert witnesses that give reasoning. Well, I would call a trial critically important to someone, especially if they are the one on trial or the victim of a crime, right? So that's an extreme situation maybe, but some others I came up with might just be like a referee in a sporting event. As I'm recording this, the World Cup just ended about 2 or 3 weeks ago. I mean, the referees in the World Cup, that's kind of a big deal. They make calls. They have to know the rules, which are reasoning, and they can go back and look at the rerun of evidence. Those are the kind of vibes you're going for here. In our learning intentions and success criteria here, we're telling them today we're learning about claim evidence and reasoning so that we can write like scientists, because that's part of communication. Also, speaking is part of communication. Debating is part of communication. But ultimately, one of our science and engineering practices clearly laid out is arguing with evidence. Arguing with evidence, whether we're doing it verbally, whether we're doing it written, however we're doing it, it's a goal. So that's the so I can. This is the what and the why. And now what they're going to do in this lesson, I'll show you in detail in just a moment, is to use an interactive web tool because that's my world. I work as a cyber school teacher. I don't have a whole lot of hands-on tools I can rely on. So every single day, I'm going to the internet for something so I can immerse students in the thing. And no, there is no interactive web tool that I know of that really immerses them in CER until I created one, which I'll show you in a moment. They're simply going to read. I like to bold my verbs because science and engineering practices are my goal every day. Reading may not be one, but there's more. They're going to read conversations between people with 3 different professionals to identify and record the claim, evidence, and reasoning in each conversation. They're going to analyze their summary of those conversations to summarize their similarities, what's similar about them, identify for themselves what's the claim, what's the evidence, and what's the reasoning, and then use evidence from those portions of the conversation to argue how to prepare each part in general in the future. So notice what we're going to do here is give them an experience in which they can observe, think through, and come out with their own conclusion about a writing style. Now, at the beginning of most lessons, if I have special terminology, I'm laying it out there. I'm purposefully not defining it. This is something students are going to come back to in the end and do themselves. So here we have our task instructions for using this interactive web tool. And all we have here are just basically down here some bullet points about how you can use the tool itself, because I don't do demonstrations, not in the high school. 10th, 11th, 12th grade should be able to follow some instructions to find your way through something. And truly the essence of inquiry is, even if you can't, you're going to click and see what you get and think about if that's what you need and look around and click somewhere else, right? You got to find your way through the essence of science. But I give them minimal instructions, certainly, and show them where the most important places are to click, especially if I'm not using the tool the way the tool was intended to be used. Sometimes that happens. Here, just telling them to choose the first conversation they'll observe, then record information as you gather it. So I do want to point out here that the next page in this lesson is their page, and I will drop this in Seesaw for them to make their notes. Again, using Seesaw because it creates a wonderful catalog of student work artifacts throughout the year. And because I'm giving them one every single day, it becomes a reliable digital place that they can go back and see a whole unit or a whole semester's worth of their work product with interactive links to all the tools so that they can even rework through, rediscover whatever the core ideas were in that challenge. So you can see in their student artifact here, what I have them doing is pulling out 3 conversations. Now, what we're going to look at in a minute is there are 10 possibilities. So we're building in student choice here, agency. I'm not forcing them to look at just 3. I want them to see that there is an array of professionals, array of conversations that can happen in life that use CER. And I don't want them to see that they are in fact just upper echelon academic styles like lawyers and doctors, but people who are really down to earth, like chefs and dog trainers. So they get their choice, and that might also be a starting point for conversation for me at the beginning of the year to see what students are interested in. Or maybe they're just really flexing their curiosity at this point. Maybe you wouldn't expect a dog trainer to be using CER. 3 conversations, listing the professional conversation they observed, writing what they thought from the conversation was the claim, the evidence, the reasoning. And then once they have completed this, they're finding what's similar. Why did you classify that statement as a claim? Why? And so on for evidence and reasoning. Okay, this is a tool I created in a really awesome web program called Genially. Feeling like this year it's going to be my go-to for creating that immersive experience that may not otherwise exist. And I do have a few places in my chem content at least that could use that. So looking forward to it. Calling it the power of persuasion. And what we do here is we just click on one of our professionals to listen in on the conversation they might be having. Let's go with the chef first. I really like that one because so down to earth, so relatable. Presumably you're watching me on YouTube or maybe on my website in the blog. We go to YouTube all the time for all the things, right? So we're opening this up and we're seeing a girl is looking at YouTube, which says, this is the flakiest pie crust. And she's thinking to herself, hey, I've tried everything, but we'll see what you have to say. And you can click on that to expand it so that everybody can read it. It's a little bit more accessible. There's prompts to continue going. So the conversation is revealed in 3 frame pieces with this sort of comic book look style. In the middle, the chef says, if you want the flakiest pie crust, keep your butter as cold as possible. Now you and we know that's the claim. And that's a little tricky in this lesson because most of them are set up so that the claim is in the first frame. But by the time they get to the chef, unless they're pulling it out first, they're realizing, hey, it doesn't always have to be at the very beginning of the story. So keep your butter as cold as possible. And then we get a pop-up here that are eyeglasses. And what we want to emphasize here is that in science, evidence is not quoting someone like it might be in literature class. Evidence is going to be something we're encountering and we're using our senses to collect it. So here we can see when the butter is too warm, what the crust looks like. And if we use this slider, we can see when we use ice cold butter to start out, we get this flakier layer. Now, when we're first looking at this, we're going, oh, okay. That's what the chef said. She said, if the butter is cold, it'll work out flaky. And so what we want students to see is that this evidence supports what she's saying. She's proving it. She's pointing it out to us. Now we need the rest of the story. And what I like to always write on student feedback when I'm reading CERs is, but why? If I could always ask, but why, then you're not done. But why? The reasoning is the fact. The thing that they should have learned in the course of doing their science classes, the core idea that will support all of it. It's the logic piece. So we can click on this and she's thinking to herself, how can that be? How can the temperature of butter make that much of a difference? And she goes to explain. Now, no, she's not a scientist, but she's telling you what happens. This cold butter, when it gets in the oven, it generates steam and the steam puffs up the layers and so on. And so it gives us an explanation of how. And with those 2 pieces, the fact that it's actually happening, we could see the evidence and there is a solid explanation for it that our students aren't going to think of as if it were science. We have a complete response. And then students can go on and select any other of these professionals to peer in on their conversations, but they all take the same vibe. So going back to the lesson here, definitely I've gone through and I identified all the different parts. Some cases, there's more than one piece of evidence. Like when we look at the lawyer's got fingerprints, but they've got also security footage and a receipt that shows they weren't, and the salesperson has a couple different pieces of evidence, but there is reasoning that connects only to one piece of evidence. And so not included in the lesson, but definitely we want to hone in through the rest of the year is which evidence is the most convincing, right? This lesson might get our students thinking about that also. So ultimately, we go back to that word wall. Remember I said I always pose them a word wall at the beginning. I say, these are the terms of concern today. You're going to come out understanding them better. show me how. What I want students to do is use their conversation observations and the similarities that they already looked at. So it's not enough to say, what's similar here, because then we have an extra dimension to think about. So we see that in general, the claims are short and to the point. Other people might disagree with them. Maybe they could be opinions if we don't include the evidence in reasoning. Whereas the reasoning are all super long. They're longer than all the other parts. They're very, very detailed, and they're not common knowledge. The evidence always describes something we can see or experience. And so they're taking those generalities, those similarities, and now they're saying, well, then what is the claim doing? What's its job? If this is what's similar between all the claims. And then what would be your tips for writing your own? And so we come out with something like, what we want students to do with claim evidence and reasoning. Claim answers the question. Evidence describes what someone can observe. Reasoning provides the detailed facts. And then, of course, we can go on with some discussion pieces, but ultimately we want students to come out with their own tips for writing it. And of course, you're delivering this in a classroom. This becomes a whole group collaboration where people are suggesting some ideas for things. And so maybe what one student didn't think of, they're jotting down. So we are taking notes, but we're taking notes from knowledge we're constructing together. Students mostly, teacher guidance, and a little bit of leadership. Totally awesome. And you know what they can come out doing in the end? After all this, they should be able to construct their own fictitious conversation where they are the expert, which again, at the start of the school year is so excellent as a springboard for getting to know them, because I've had students who have small businesses on the side, like repairing small motors. Like I had a student who repaired lawnmowers and chainsaws and all the things several years ago. Other students who are, professional dancers, and they have their own areas of expertise. Even the average student who just loves to game, they can write about their gaming and come up with this conversation. But maybe not in a creative writing kind of comic book storytelling kind of way. Instead, we're making it very relatable for them here, bringing it down to earth in their world, putting it on their cell phone with their little text bubbles, and showing that exchange of conversation. And so all in, this really isn't even a lesson about CER. I mean, that's what we're trying to achieve, but it's really a lesson in helping students realize that CER is not just for science, that evidence matters and how it matters, that reasoning matters and how it matters, that ultimately the only way we understand each other is by communicating clearly. Whether they're scientists or they're simply making simple decisions throughout their lives.